Now our next topic today is the what are batteries. Basically the commercial batteries. I'm talking about now the commercial cells. Like we use the dry cell in our clock, lithium ion battery in our mobile phones, right? And we use the lead storage battery for our inverter or for our car battery, right? So basically batteries are the electrochemical cells, but they have been designed in such a way that even the person who does not know about the electrochemistry, has never studied chemistry, he can also use it conveniently, right? Getting me, all of you? Right. So batteries are arrangement of galvanic cell in order to obtain the higher voltage. So there are two types of batteries. Number one is the primary batteries, those which cannot be recharged. You have to use and throw. That's it. And secondary batteries are those which can be recharged. Like we have a lead acid battery cell, lithium ion battery cell, nickel cadmium battery cell, right? These are rechargeable. Primary cells which cannot be recharged, you have to use it and then throw it. You cannot recharge it, right? Yes, any doubt till now? You can ask me right now. No doubt. Okay. All of you can please chat with me open. Why you are sending me the private message only? Okay. Now I discuss about the primary cell. Here I am not discussing what is dry cell, or commonly called as the Leclanché cell, right? You have seen the that common cell that we are using in our clock. It has outer cover of the zinc, right? And inside, have you ever broken the cell? I'm asking you, have you ever broken the dry cell and seen what is inside it? No, it is not dangerous. You try it. You can use your used cell, cut it from there, cut it, right? Today, you please try it in your used cell, right? So the outer metallic plate is basically made up of the zinc, and inside you will find. Please try today, all of you, right? It is not dangerous. We should be very, very practical. You must play with such type of things, right? I have broken many cells, many cells, when even I didn't know about all this electrochemistry, right? So when I was a student of, I think, fourth class, fifth class, sixth class, all my cells that were used in my clock or something else, I used to break it with my stones and everything and open it up and used to see what is inside it, what is giving the current. I could not understand at that moment, but later on when I studied in the +2 level, it was very clear. Okay, so Chitransh, I think you have done some experiment with the cells, right? Have you done it right now? Yes, Chitransh, have you done it right now? Okay, perhaps earlier. Okay, good. Chitransh have done practical earlier. So here we have a black color, black color rod, basically that is made up of the carbon, and around it there is manganese dioxide, MnO2, this, and carbon, and a paste of the ammonium chloride and the zinc chloride is here, right? So in a new cell, you will find the paste, right? Have you ever seen a leaking cell in your torch or batteries or something? A cell is leaking, some liquid comes out of it. No, okay, Neha is saying, okay. Be very like you should see it. Whatever is happening around you, see it. There is a chemistry there, right? So what you do, those who have not seen, please fix up a cell in your torch or something in which it is working, and don't remove it. Don't remove it even though you are not using the torch. Otherwise, in the batteries, it is written that you must remove the batteries when it is not in use. But now I'm suggesting you to fix it in the torch and leave it as such for, let it be for 10 days, 15 days, 15 days. When you open up, you'll find that the cell is leaking from its top. Right? So that leakage is basically the paste to the zinc chloride and the ammonium chloride. Here we have zinc chloride and ammonium chloride. Right? Are you getting all of you? Are you getting me? Yes. So when you connect it to the, let it be, I'm connecting it to a bulb. This zinc undergoes oxidation and an ammonium ion undergo reduction here. MnO2 undergo reduction here. So if I have to balance the two equations, multiply here with the 2 and cancel out the electron here and add the two equations. It is giving a voltage of 1.5 volt. 1.5 volt. Am I clear? Now, the function of the zinc chloride is the ammonia gas that is produced here. The ammonia gas that is produced here is combining the zinc ion to form a complex. If this complex formation does not take place, what will happen? This ammonia gas will exert pressure in the on the wall and the cell will burst after some time. To avoid this bursting, this ammonia is now making a complex compound with the zinc ion. Now it is no more free ammonia available in the cell. Right? It's a very important question for your board level also and at the competition level also. What is the function of the zinc chloride? That if ammonia is producing here, you can see here ammonia is producing here, and if it is not trapped somewhere, then it will be exerting some pressure, and that pressure can burst this cell, right? So it is trapped in the zinc ammonium complex, right? So what happens if you see the overall reaction here? Very important overall reaction here. If you write the Nernst equation here, it is the concentration of this complex ion upon ammonium ion concentration. With the passage of time, what will happen? The concentration of the product will increase and ammonium ion will decrease. So the EMF will be not constant, but it will be varying. It will be changing slowly. So total EMF will be slowing down after some time, right? Have you ever seen in your clock that initially it gives the right time, but when the cell is about to get over or getting exhausted, it gives time slow, late time. Have you ever seen this? Right. And even if you don't change that cell, first of all, it is getting late by, let it be 5 minutes. After some days, it will be getting late by 10 minutes. Have you ever seen this thing in your clock in your room? Right. So after some time, what will happen? It's only it's a needle, that second needle will be fluctuating left, right, and after that also it will stop. This thing you have also observed, right? If you don't change the cell, let it be, let it get over. So first of all, it gives a late time, and then the second needle starts fluctuating at its own position, left, right, left, right, left. Because now power is not so much left over there that it can move the needle of the minutes and the hours, right? So basically, the EMF value is decreasing because in the overall reaction we have these ions, and the ions are first of all increasing with the passage of time, right? Okay. And now yes, whatever you're telling me, if you give extra voltage, then it will show some different time. Okay. Okay, now we discuss about the mercury cell now. Very important here. This is a mercury cell here. And again, we have a mercury zinc container, and inside it we have a mercurous oxide, HgO, and basic medium is there inside, that is OH ions. At anode, oxidation takes place. At cathode, it is reduction taking place. And the overall reaction, if you see this overall reaction, we don't have any ion. So it gives a constant value. It gives a constant value of the EMF, and that is being used in the electronic watches. Have you ever seen that electronic watches never give the late time? When the cell is about to end, it just stops. It just stops, but it does not give the late time. Are you getting me? Right. These days we are using basically electronic watches. We put up the cells inside it, right? There used to be a wristwatch also, in which there were like we have a needle. We have to again, chabi bharna, something like this, right? These days we are not using that type of wrist watches. We are using here electronic watches. Where cells are there. We put up the cell there and it keeps on working. So it does not give a lead time because the EMF is constant. If you write the Nernst equation, there is no any ion. So the EMF will be equal to E naught value. I hope it's very clear now. So mercury cell uses low current device such as hearing aid, watches, calculator, right? If you use high current devices, then electrolyte will go consume faster. As more current means more electron flow, which means anode and cathode will be consumed faster. So basically, these are used in the watches, calculator, low current devices. Yes, yes. These days we have such devices which are working upon the mercury cell. Yes, we can use. But that mercury cell, have you seen the mercury cell? It is a very, very small cell. Have you ever seen that? We also call it as a button cell. It's a very small, right? Yeah, that is in watch. That's what I'm asking. I'm telling about this mercury cell. That is a button cell, like a button, very small, silvery white button. Yeah, yeah. Button cells are mercury cells. Chitansh, now you're getting me. Yes, I have discussed about that button cell, and technically in chemistry language, I'm talking about the mercury cell, right? Technically, it's a mercury cell in terms of chemistry language, and in common language, when you go to the market and ask for the cell for your watch, they will ask you, do you want a button cell? Yeah, button cell. Got it? It's very simple. Okay, because they don't know they don't know the technical terms. That shopkeeper or watch repair person. Okay. Now talk about the secondary cells. Secondary cells are rechargeable. Very important now. I'm now talking about it. Secondary cells are rechargeable. And in that, first of all, I'm using the word nicad cell, nickel cadmium cell. They can be recharged. Cadmium rod is there and nickel oxide in the basic medium. Cadmium undergoes oxidation and nickel oxide undergo reduction. In the overall cell, you can see there is no any ion. It gives a constant voltage of 1.4 volt. And it can be recharged. It can be recharged. Right? Are you getting me, all of you? All right. Now, I'm going to be discussing about a very important cell here, lead storage battery cell. Lead storage battery cell. In this cell, we have here we have a concentrated sulfuric acid, that is 38%, and lead and lead oxide. Two grids are there, alternatively placed. Lead is connected with the anode and lead oxide connected with the anode part. When we connect it, Means suppose, I hope you might have seen that inverter in your place, in your house. There is a battery connected over there. UPS, yes. UPS is there. With your computer, there is a UPS, yes. And yeah. So when there is a power loss, power is lost, power has gone, then it starts working. It means this acts like an electrochemical cell. This is a electrochemical cell where the chemical energy will be converted into electrical energy, right? All of you getting me? So what will happen in the discharging lead in the presence of sulfuric acid. This is coming from sulfuric acid. It is getting oxidized. Lead oxide that is at the cathode undergo reduction and it undergo reduction. Then if you add the 2, it is giving this value 2.04 volt. And you can see in this the sulfuric acid is getting consumed. Sulfuric acid is getting consumed. And with that the density goes on decreasing of the sulfuric acid. Earlier it was 38% by mass, and now when it decreases to certain level, and have you ever seen that in your home, uh, the inverter starts beeping when it is about to end. Now that power has not come, but the power, the chemical energy has been converted into electrical energy, and very less amount of energy is left over in that battery, and that inverter starts beeping. It gives beep that now please shut it off, and it cannot provide no more energy, right? So this happens now. Now it needs recharging. It needs recharging. In that recharging, what you have to do is you have to make the anode the cathode and the cathode and an anode. When the power comes back, now that electrochemical cell become an electrolytic cell. I repeat, that electrochemical cell becomes the electrolytic cell. And there the anode becomes cathode and cathode becomes anode. So you can see this is the anodic reaction. Make it reverse. Make it reverse. Recharging is going on. Make it reverse. Make the cathode reaction reverse. Right? Have you ever seen that after some time you have to add water to the battery? In your home you might have seen this thing. You have to add water to the batteries after some time. Have you ever seen? So you can see here, I'm adding water here. I'm not telling you the chemistry behind everything that you observe with your battery and inverter. Is that clear? So this is the overall reaction for the recharging reaction. So it's a basically it is a rechargeable cell. It is a rechargeable cell. It is getting discharged here and getting recharged. So you have to remember these reactions at the cathode, at anode. Car battery can be recharged by water. No, no. We are not recharging it by the water. We are recharging it by providing the electrical current only. In a car battery also, what happens whenever the car is running, when the car is running, that chemical energy of the fuel that we are using in the car, diesel or petrol, that is giving current to the battery to get charged. Right? I hope your doubt is clear now, Dikansh. In the electric cars, we have to recharge it. Right? Why do we add water here? See, the equation requirement is here. If you add the two equations, I'm adding by the chemical reaction, I'm adding here water. So this is what our chemistry is indicating here, that we have to add water. Right? That is why we have to add water. Now we talk about the fuel cells. Now I will talk about what is the meaning of fuel cell. Fuel cell is the one in which we are providing the fuel, and it will keep on working until the fuel is not completely consumed. Until the fuel is not completely consumed. So that is called a fuel cell. And we will be discussing about the hydrogen oxygen fuel cell. We will be using here hydrogen oxygen fuel cell, right? And it was first of all invented in 1975 by NASA. I hope you know what is NASA. You know, everybody knows NASA. Okay. Do you know about the ISRO? Okay, fine. So what is the full form of ISRO? Indian Space Research Organization, right? Can you tell me where it is located in India? Bangalore? Yes, no. I don't think in Bangalore. It's in Hyderabad. Okay. Please confirm it from the net whether it is in Bangalore or it is Hyderabad. Please check it. Check it. Launching sign is at Hyderabad. Okay. Launching station is at Hyderabad. Okay. Please check it from the net whether it is where it is there. Okay. Indian Space Research Organization. So it was first of all that fuel cell was invented by NASA. Why was it invented? In 1975, there was a Apollo moon flight. Mission was there, Apollo moon flight. In that mission, there was a 11 days mission in which that satellite, all the crew members have to move around the sun for 11 around the moon for 11 days, and they have to come back after all doing some research work over there, right? And the electrical power that was required at that time was so much that if they have to use the thermal power plant, they would have to burn 2000 kg of coal, and that will be converting into the electrical energy, and that will be sufficient for the whole of the mission for the 11 days, right? It means along in their rocket, they have to carry 2000 kg of the coal and then thermal power plant with them. That was not possible because we had to, in the rocket we had to launch against the gravity, and we need certain escape velocity. So it was not possible to carry so much amount of weight along with the rocket. So what they planned is they just took 100 kg of the hydrogen and 100 kg of oxygen, right? That's it. And that was sufficient to make such a device. We call it as fuel cell. I will explain how it is producing energy, electrical energy. That was sufficient for the 11 days working of the for everything in that 11 days mission. And even when they came back on the earth after 11 days, that fuel cell was still left. One more trip could be conducted in that one, right? So what is that and how it is working, right? They were invented by NASA in that emergency. Now I'm discussing that. So what it is basically, here we have inlet for the hydrogen. See here, here's the inlet for the oxygen, and this is a pore. This is a porous carbon electrode and containing metallic catalyst. And the oxygen, you can see, undergoes reduction. Hydrogen undergoes oxidation. Overall reaction is this: hydrogen is undergoing oxidation and oxygen is undergoing reduction, right? And it seems that you can see it's a burning of the hydrogen. Overall reaction, if you see the overall reaction, it is the burning of hydrogen. Yes, I'm coming to your question. I'm coming to your question. Right? So that is why it was called as a fuel cell. Until unless we are providing this hydrogen and oxygen, the cell will keep on working. Right? So the fuel efficiency is 70%. You're telling me 80% somewhere. Okay. And now question here is, yes, you are asking me why they are not preferred. Why we are using lead storage battery cell. Yes, all of you, talking to everybody here. Everybody present here, attending, listening to me? Yes or no? Okay. If you remember, I hope you might be in lower classes. Some 5-6 years back, there was a trend of using the LPG in cars instead of diesel or petrol. Some cars were having a different system of using the LPG, liquefied petroleum gas. But nowadays these are not seen on the road. No, these days are not used. Reason being, that hydrogen gas was there, so LPG gas was there, and that was very, very like explosive gas, right? In the summer season, there it was observed a lot of accident on the road, which was not due to the collision between the two vehicles, but it was just a car is moving and suddenly there is a fire in the car. That LPG got so much amount of that energy from the sunlight, from the heat of the sun, that it exploded. Right? So later on, the government banned that LPG. Right? Some inbuilt systems were there, some external LPG systems were there, but nowadays these are very, very less. I don't think there is any. Right? I don't see any car that is having an LPG system along with it. We are using the LPG simply fuel cell as a liquid petroleum or petrol or the diesel that we are using. Similarly here, if we use here hydrogen gas, see here, very important, hydrogen. It's a highly explosive gas. It's a very, very highly explosive gas. And common man cannot handle it very easily. Right? So these are not used. CNG, of course, it is being used. Yes, Anirudh, CNG is being used. It is not that much explosive, but there is a perfect system there that it does not catch fire easily. And moreover, now I'm telling you a very important fact. The water produced is there. Water is getting produced here. And for that 11 days, very important, all the astronauts use the water produced by this for the drinking purpose. Even they did not carry the water for drinking purpose. They knew that water will be produced by the fuel cell and they can consume it. Right? So the weight of the rocket was reduced a lot. Are you getting me? Everyone? Yeah. And now our next topic is what is corrosion? You know, very simple topic about this, right? And methods to prevent corrosion. Corrosion is basically deterioration of the metal in the presence of atmospheric oxygen, and the metal get converts into the oxide, sulfide, carbonate. Particularly in case of the iron, we call it is a rusting. Particularly in case of iron, we call it rusting, right? So we'll be discussing about the mechanism of rusting. In our syllabus, we have mechanism of rusting. So this iron, iron is having a rough surface here. You can see water particle can get trapped over this rough surface, and oxygen goes inside it, right? So what happens here? Now see the mechanism. What happens in this one? This iron has a higher oxidation potential as compared to the oxygen. So iron undergoes oxidation and oxygen undergo reduction to form water. So iron plus oxygen, you just adding the equations, I'm getting here. ferrikine, and this ferrikine combine the water molecule to form a rust. This is the formula of the rust. Are you getting me? Let me know if you have any doubt here. So iron is undergoing oxidation and oxygen is undergoing reduction here. So the formula of the rust is Fe2O3 dot X water molecule. Yes, you are right here. Here I should write here X water molecule. Yeah, they have written here. I hope it's very clear now. All right. Now, how to prevent the corrosion? Painting, oiling, greasing, galvanization. Basically, we are covering it. And in the galvanization, can you tell me which element is used for the galvanization? Yeah, zinc. Why do we use zinc? Why do we use zinc? Why do we use zinc? Because if you see the reduction potential of the zinc is minus 0.76 volt and the reduction potential of the iron is minus 0.44 volt. So which will undergo reduction faster? Which will undergo reduction in these two? Iron. So which will undergo oxidation faster? Which will undergo oxidation? Zinc. So this iron piece is there. It will be, there is a layer of the zinc over here. The zinc will keep on undergoing oxidation. Even if the zinc is removed, it will undergo complete oxidation for its last atom, and that is why we call it is a sacrificial protection. Are you getting me? Some amount of zinc is removed, let it be. Even then, the iron will not undergo oxidation. Zinc will keep on undergoing oxidation and it will get removed, and it will keep on protecting the iron until its last atom. You know, until its last atom. That is why we call it is a sacrificial protection. It sacrifices itself to its last atom to protect the iron. Right? It is just like this, like Indian soldiers are fighting until their last drop of blood. Right? That's the same way. Zinc is protecting the iron until its last atom. Is that clear? Now, wait a minute. Who's asking me? Yes, there can be some other element used for this purpose. Yes, we can use, but they are costly. Zinc is comparatively less costly. So zinc undergoes yeah, its job. It's cheap. Otherwise, there are many other metals also that we can use that have a higher oxidation potential. We can use, but they are not cheap. They are costly. So we prefer the less cost. Economics comes over there, right? I hope you are getting me, right? The chapter is now very simple. In the beginning, it was a lot of mathematics was there, numericals was there. Now it's the last is going on, so it's very easy now. You have to read these things, remember it, learn them, right? All these reactions. So zinc is a sacrificial anode. It protects the iron, and that is why we also call it as a cathodic protection. It is also called as a cathodic protection. Any doubt here till now? Everything is clear? Now, this is our last topic now. What is conductometric titration? Before this, you have discussed in your +1 level, I hope, acid-base titration. Yes or no? Yes. So acid When added to a base added to an acid, they neutralize each other, and there is a color change observed of the phenolphthalein. Yes or no? You might have done this experiment. So colorless to pink, right? So in this conductometric titration, what we will be doing, basically again our purpose is same. Our purpose is same, that is to determine the strength, molarity of the unknown compound. But here we will not be using here acid based titration, but we will be using here conductometric titration. So titrant whose strength is known, titer whose strength is to be determined, right? Example, HCl and NaOH. This is acid base. Here the conductance solution depends upon number of ions and ionic mobility. I hope it's very, very clear. In the conductometric titration, titer will be taken in the conductivity cell and titrant will be taken in the burette. We know more the number of ions, more the conductance. Basic fundamental is this. Right? Till now, any doubt? Now I'm coming to the basic fundamental of the conductometric titration. Till now, any doubt? You can ask me. No doubt? I'm moving ahead. So if I take up a case here of the HCl and NaOH, case of HCl and NaOH, what you do? Let's now understand what is happening when both the electrolytes are strong. You can see that HCl and NaOH both are strong. HCl is already in the conductivity cell, completely dissociated, right? When we add NaOH, it is still a limiting reagent, not enough to neutralize the HCl we have taken, right? It means we are adding here. In this we have HCl, right? This is a conductivity cell. This is a conductivity cell here. See, I hope you understand how I draw this one with determining the molar conductivity and all that. Here we have HCl, and here I am dropping here NaOH drop by drop, right? So HCl is less in amount, right? It is a limiting reagent here. So let me case one I'm taking here. HCl dissociates as a H positive and a Cl negative ion, and NaOH dissociates as a Na positive and OH negative ion. The combination goes like this. But initially, let it be time 0, 10 millimole, 10 millimole. I'm adding here 1 millimole, 1 millimole, right? Because I'm considering that NaOH I have added very, very less amount, and it is a limiting reagent here. So 1 mole require 1 mole. It means out of the 10 mole, 9 millimole will be left here, 9 millimole will be left here. And 1 millimole of NaOH, NaCl will be formed here. Am I clear? It means the total number of cations are still equal to 10 millimole, 9 and 10 and 9 and 10. It means we will plot a graph, conductance versus the molar volume of the NaOH used here. If we draw a graph now. Now what I will find here, are you getting me? Are you getting this titration? What I am adding and how it is going on? Yes, students, are you getting me? Let me know. Okay, no doubt. Okay, should I explain once more? Okay, fine. See, Shrija and everybody please focus here. I'm repeating this topic once again. Here it is a 10 mole, 10 millimole, 10 millimole. I'm adding here Na positive and OH negative and 1 millimole each. They are neutralizing each other, right? So 10 millimole of H positive ion there and OH moles are 1 millimole. They will now neutralize. But out of 10, only 1 will be neutralized. Remaining is 9. It will be 9 because NaCl is being formed here. They're getting 0. But total number of ions remain total is equal to 10. It means number of particles are not changing. number of ions are not changing, so the conductance will remain same, right? Slowly and slowly what will happen, the number of the free Na, H positive and Cl negative will be decreasing. You can see the H positive has a high conductance, H positive ions has a high mobility, but number of ions are still, but as the H ions are replaced by the sodium ion, because what H positive is going into the water. Now we are left with the Na positive ion, which is having smaller size, H positive or the Na positive. Let me know. Which is smaller in size, H positive or Na positive? H positive. So which has lower conductance? Which has lower conductance? The smaller one or the bulky one? Yes, bulkier one. It means sodium ion will be bulkier. It will show the less conductance, and that is why you can see the conductance goes on decreasing here. See here, very important. The conductance goes on decreasing here. As I keep on adding the sodium hydroxide, we have more and more number of the Na positive ions, and the conductance goes on decreasing. The conductance goes on decreasing. Are you getting me? It is a conductometric titration. Do you find any doubt here? Yes. This type of conductivity, this type of titration is called as a conductometric titration. Right? Now, after the equivalence point, when it is completely neutralized, addition of the NaOH will come to the solution and number of ions will further increase. So, again it is moving up. Wait a minute, students. Is that clear that after that neutralization, I'm discussing, student. This is a point here when it is completely neutralized. And now if you're adding more sodium hydroxide, that will increase the concentration of the H positive and Na positive and OH negative ion. And the ions are increasing, the conductance will further increase. Right? This point is the neutralization point. Is that clear? Everybody clear? So that's all for today. And next time we'll be starting with the topic of solid state, right? If you still have any doubt, we can discuss it next time also before we start the solid state, right? That's all for today. Thank you for joining.